Chang, what time did you say you need to be in Burlingame? I can call the Waymo.
Oh, okay.
Cool. Is it okay to just take this while we go?
Sure, yeah.
Okay,
So-
sweet. Yeah, we'll just do it in the car. It says you should be there by 3. That big streaming media company, they can wait, right?
Yeah, totally.
Have you been in a Waymo before?
I have many times.
Yeah. Do you take calls while you're in the Waymo?
Absolutely.
Okay. Are you a coder in the Waymo? No. Are you locked in while you're in the Waymo?
No. Only in the literal sense.
Yeah. I guess the doors are locked. That's fair. I'm Bryan Bischof with Theory Ventures, and I'm here with Chang.
Hi, my name is Chang. I'm the CEO and co-founder of LanceDB. LanceDB is the AI native multimodal lakehouse. We help AI teams building cutting edge models or building AI applications to manage all of their data in one place. Fortunately, almost every problem can be boiled down to a search problem. And I think, especially with Lance format, the ability to do random access makes it very easy for us to support these online search workloads as well. So I think if you think about model training and research, right, data curation, exploratory data analysis, these all need search and retrieval. If you're finding an edge case, you're looking for similar situations in your data. But then, of course, we're probably all sick about hearing about RAG and AI retrieval at this point, but this is also the most important, I would say, new AI workload of the past few years.
Why do you think of enterprise data as inherently multimodal? Like, what is that mode? Why is it not just text?
Yeah, so I mean, the way we think about multimodal is, I would say in kind of 3 different senses. One is that the data that we deal with are now much more varied. Number 2 is, I think the workloads that you can perform on your data is also becoming much more multimodal, in the sense that, if you think about BI or dashboards, a previous generation of data infrastructure, you had this like OLAP types of workloads where most of the focus was around analytics. And the end of that process was generating dashboards that can be used to make data-informed business decisions.
Sure.
Whereas I think with AI now you have, you might be training a model. You might be doing some data transformations in support of that training process. You might need to build a data-intensive AI application. So then the model, you have to somehow connect your enterprise data to the model. So you need search and retrieval capabilities. Then I think a third aspect is, previously you always had to choose between, okay, this system is only good for offline batch kind of workloads, or okay, it's only good for online serving point query kind of workloads. Yeah. And so, in my previous jobs, I had to deal with it. And the consequence of this was you had this like research to production gap where you had to rewrite code for this other system and copy and transform data for this other system. And there was a lot of energy devoted into fixing errors in that process and like dealing with failures along that pipeline. So that offline online divide is another dimension in which we think at least LanceDB can be multimodal. Lan and I were inspired by this old Stephen Chow movie called Kung Fu Hustle. I don't know if you've seen that one.
Yeah, of course.
And I think I did a presentation on that where I wrote down, this is, I saw a recent movie and then I realized it came out like 15 years ago or something like that. And I felt really old.
Yeah.
But the main villain in that movie, I think his famous quote was, in the world of Kung Fu, like speed determines the winner. And so I think it's the same case for, labs that are training models. It's all about how fast you can iterate.
Right.
I think we can talk about different vector databases or different search techniques, but what it boils down to is, retrieval is the way in which we can connect our first-party data with the model or with your agent. And at the end of the day, that I think that is actually the critical factor in how good your AI is, right? Because like tons of companies are building AI, but nobody lost out because they didn't have access to an OpenAI model or an Anthropic model. But if you don't, if you're not successful in connecting your data to the model, then you can't differentiate your AI features from that of your competitors.
Totally. One thing I wonder is like, what is great about Lance for retrieval? Is it the format itself is this like really great for retrieval, or is it more that the format allows retrieval with all these other benefits for like the data type and sort of like the data location and things like that? Is it the former, or is it something neither of those? Is it more about sort of like the platform and like the way that you built the system around the format?
Yeah, I think, talking with our customers like, Netflix and like Uber or like Harvey, I think what I hear the most is actually split into kind of three sort of layers. One is, of course, the file format itself. One's being open source, they can put all their data together. Two, it supports fast search, and also it's an open layer. So, you can store your data in Lance format and just have open access to it from any part of your tool chain. And then on top of that, our vector search engine is very different from traditional vector database architecture. So traditional vector database architecture is kind of very much like Elasticsearch, where you have a bunch of different nodes. There's no separation between compute and storage, and then the indexes have to be loaded in memory. So it's incredibly, I think, wasteful, because with AI, I think there's an explosion of data volume. So you might have, easily for growing startups to get to like billions of vectors, but the actual workload can tend to be very spiky and grows much less. So with a system like Elasticsearch and other traditional vector databases, it's incredibly expensive and incredibly wasteful, and it's hard to scale. And so the LanceDB Enterprise vector search engine changes all of that with a completely different architecture.
I see. So what is the architecture?
So the architecture is, we go from this shared nothing architecture to a shared data stack where all of your vectors are stored in an object store. And then we have a stateless query fleet with a caching fleet that then allow you to get the cost efficiency of object store with the performance as if the data was stored in memory, and very easy auto scaling. So,
and how many indices can you have in like a Lance table? Is this like you have one index and you kind of like, that's the one that you're using for most of your search problems, or are you doing multiple indices?
Yeah, so I think for a lot of our customers, the fact that LanceDB can support arbitrary number of vector indices is a huge plus in two sort of use cases. One is there are tons of embedding models out there, and so you always want to do experimentation to find which is the best one. So most traditional vector database technology only supports one per collection, so that if you want to do these types of experimentation, let's say like I want to look at the top 10 MTEB benchmark board or leaderboard or something like that. Now I have to copy my table 10 times just to get a sense of which model works best. Whereas LanceDB, you could just add 10 columns incrementally and then just pick the one and drop the rest at the end. So that's one big use case. There's another big use case, which is for multimodal data. So
for that, I think we should enter the alpha zone.
All right.
So indices for multimodal data.
Right. So I think with multimodal data, so if you take an image or a video, there are tons of aspects about that multimodal data that you can search on. So you might want to describe literally what's in that video or image. Like, there are 3 people on a road and 5 cars, and you could have information about like the colors or the feeling or the mood, and then you might have descriptions and metadata around the date, maybe an author or an artist, and things like that. So
I see.
You're going to want to have different embedding indices and embedding columns to represent different aspects of this multimodal data, and search along all of them potentially. Or for our customers, their alpha came from that realization that search is more than just a single vector index.
Right.
It's about supporting different vector indices, and then also a full text index, but then also to be able to store metadata and even the raw data that you extracted your index from.
I guess one rejoinder that I might have is the bitter lesson. I might say like, okay, well, the bitter lesson tells us that we should actually just like dump more and more into a really big model and not worry so much about like hand tuning features. And so, you know, one might ask instead, well, like, okay, Chang, like it's neat that you can sort of like index so many times and search over all those indexes simultaneously, but like, wouldn't it be better to just like have a better embedding model that like really just like jammed all of the different kinds of search into this one embedding model and then have a good fast search on that? Maybe I could even get like better performance characteristics because it's only one index. What say you?
That's a really great question. And I think, unfortunately, I would say that one, no embedding model is good enough to capture all of the data and insights that you want, and also be good at answering all of the questions that you might want to ask. And because at the end of the day, what embedding models do is they essentially project your data into this latent space. And the way that it constructs this latent space means it's only good for a certain class of data and certain class of problems. And then even as embedding models get better, there's always the question of, well, what data are you actually feeding into that embedding model? Is so to be able to store the input data, do a bunch of experiments and data transformations on that input data is still super useful.
In this search problem, you know, like I think there does seem to be an absolute like explosion of search applications. I guess like, why is pgvector not enough? Like, why can't I just run a parallel pgvector search and a full text search in Postgres and move on with my life? Like,
Yeah, totally.
Why do I need Lance?
Well, I think one big thing with pgvector is that it doesn't scale very well. It's single node. So I think a lot of our customers actually come to us from pgvector. I think there's nothing wrong with pgvector when you just first start out. Maybe your data is already in Postgres, but as you scale out, you scale up in terms of number of vectors that you have to search through, and then also if you need to scale out, because a single Postgres instance wouldn't be enough to support your search computational needs, then you need another system. Typically, we see that inflection point around maybe like 20 million vectors.
Okay.
And so that's one big one. The other thing is in how the Postgres query planner deals with the vector searches. And so even if you build an index, when you add filters and other search criteria into your SQL query, it's very easy for the query planner to actually skip using the index and go back to brute force search. So a lot of our users coming from pgvector will talk about how if they look at a query wrong, the latency goes up, from under a second to like 10 seconds.
Does that appear in like the P99 or is that more in like the P90 that you're seeing that?
It's both.
Oh, yeah. Interesting.
Yeah.
So it's happening that frequently.
Yeah.
Interesting.
Because it's not just about, because you would see it in a P99 if it was, let's say there was some problem at high CPU utilization.
Yeah.
But this is actually skipping the entire vector index and just doing brute force search. So it would even show up in like P50.
Wow. Okay. So it's a pretty pernicious like issue. I see. But that's interesting. We didn't really talk about this, but I am curious, like things like, filtering as part of your search. Like I know, back when I was like, using Face at Stitch Fix, like we didn't have this concept of pre-filtering in Face. It was kind of annoying. Can you tell me a little bit about pre-filtering in Lance and kind of like why people need this?
Yeah, absolutely. So great example would be something like, I wanna run the search, but only within a specific set of documents. This might be something like the user only has access to documents for marketing or sales, but not engineering.
Yeah.
And so you would need to filter the results. And the reason why we call it pre-filtering is there's two different ways to filter your data. So you could run the search, get your top 10, and then run the filter on your results. So this is called post-filtering. And the problem is there's no guarantee that you'll have any results after the filtering.
Yeah.
We see a lot of this with our customers that are building agents on top of LanceDB. And of course, we talked about this a few weeks back, and that agents doing search kind of completely upends the, I would say, data infrastructure requirements for search. So you go from this, human input query and one shot and done kind of retrieval and generation process to a totally new search paradigm. Well, I think instead of one shot, the biggest difference is now agents can iterate on the search. And so you think of search from like just one query to an iterative funnel of search results.
I see.
And along this refinement process, right, you see a ton of differences. So one, agents can issue tons of queries in parallel. So the load on vector databases and search engines are going up because of agents. Number two, agents are forming the queries themselves, as opposed to you only have humans that are doing that. So whether the agents are formulating good queries, I think is another big factor into their success. And then I can only deal with so many concepts in my head. So if I'm manually constructing a search query or a search system, there are only so many factors or search dimensions or search modes I can think of. But an agent doesn't really have my limitations.
We know what superhuman Go looks like, but what does superhuman queries look like?
I think superhuman queries would be something like, a user issues a query or maybe a command or something like that. An agent would be firing off dozens of queries at the same time, or even hundreds of queries, that then helps it to quickly narrow the space. So I think it's not so much about whether the agent can formulate the exact query that's going to get you the exact result right away, but it's how quickly the agent can iterate on that search space and narrow it down.
Got it. All right, so you've told us you've got this rapid feature engineering. You can build lots and lots of different features. Those features can lead to different search patterns. They can be across different search strategies. Some of them can be full text, some of them can be vector, some of them can include complicated pre-filtering, and you can use SQL and stuff like that. So you can do this huge diversity of kinds of search. You've also told me that agents are going to be doing superhuman search. They're going to be doing superhuman search by really complicated query parameterization and really clever way of accessing multiple indices simultaneously, maybe spitting out sub-agents that are actually responsible for their own little sort of query on their index that they're the master of. And you can think of this massive query writing process. And so I guess my question to you is in the future, why do we need vector search at all? Doesn't this actually kind of imply that vector search will die? Because if every query that a user gives me, I have hundreds of agents or maybe thousands of agents that are responsible for haranguing that query into these more and more nuanced and vanishingly inexpensive features, does that say in the limit that actually vector search goes to just unnecessary?
Well, I think search techniques will evolve, but at the end of the day, vector search is all about quickly narrowing down the search space, and how many features you have, or whether it's agents or humans doing the search, you still need to be able to narrow the search down very quickly, narrow the search space down very quickly to do fast retrieval. And this is even, I think, a bigger requirement when agents are searching, because if you have a ton of search queries, if you have one search query, let's say, you can tolerate a little bit longer search time. But if you have a 10-step sequence for an agent, then you don't want to be sitting there forever waiting for each search result to come back. And so I think, vector search will only become more important as agents become more ubiquitous.
I see. And so the point here is the embedding model, the encoder, is going to be learning some important features about your items that you want to query. And by doing that, you can really, really speed up the retrieval process for the things that you know about ahead of time. And so the agents will just like augment that piece from the intelligence side.
Yep.
I see. It's interesting because I hadn't previously put together 2 and 2 that like sort of baking in your priors is the vector search part and the agents are sort of the adaptability and the variability. Yeah, that's a nice like sort of delineation between those.
Yeah.
Yeah. Awesome. All right, so let's ask you some quick questions, some QQs as we call them. If you could go back and you could change one thing about pandas, what would it be?
Oh, that's not a quick question at all. One thing about pandas, I probably would change. I would probably think about the indexing system as the one thing I would change, because it's incredibly confusing for a lot of users. There's so many ways to index and slice into your data frame.
Okay. What's your favorite data type to index?
Large binary blob.
Perfect. How many chunks do I need for my documents?
That's also not a quick question at all. I mean, the answer is at least 1.
Okay, perfect. If you had to be quantized, what quantization scheme would you like to be quantized with?
Ooh. I would want to do. You know what? I think I would want to do PQ just because it's the most reliable.
Okay. So you think of yourself as a product?
Yes. I've been productized. Chang is the service.
Yeah, you've heard the model is the product. The Chang is the product.
Yes.
Awesome. Thanks, Chang. This was fun.